Hello all. So as a continuation of my lecture series in control systems, in today's topic we are going to discuss about impulse and step analysis of first order system. So in the previous lecture we have already discussed about what is time response analysis and definition, and along with transient and steady state analysis, and what are all the limitations without which we are going to know what are all the limitations and what we have to do in order to bridge the gap between the technology and today's applications. So in the recall part, we are going to know about what are all the key performance metrics and what is the first order and second order systems and standard test signals. So in the previous lecture, we have discussed about the standard test signals like step, ramp, impulse and parabolic. And today's lecture, we are going to discuss about the first order systems. So, introduction to first order and second order systems, fundamentals of first order and impulse response of first order, step response of first order, and RC and RL circuits as first order systems. So this topic is very important and why we have to go with, which is the real world electrical problems like signal processing, transient behavior in power electronics and switching circuits in digital electronics. These are all the basic real time problems, and what is the impact if it is not solved, which is signal distortion may happen in transmission and system instability and oscillations may occur and power inefficiency in the circuits. So if we are not going to solve these problems, so these are all the impacts which we are going to face. And what is the need for the solution? So limitations of existing methods like classical analysis requires complex calculations. So some of the analysis we requires complex calculations, but today we have many number of tools and softwares without which we can implement and check before we go into the hardware part. So manual techniques, which is time consuming for multiple inputs, and approximation errors in non-ideal conditions. So coming to fundamentals of first order systems. So we have what is order and the type of the system is the power of the S makes the order of the system, where definition and characteristics. So system with single energy storage element, which is called as first order system, which is characterized by first order differential equation, which has one pole in the transfer function. So G of S is equal to K by Ts plus 1, where K is the system gain and T is the time constant. So this is the example for first order system. Response of first order system. So we have a mathematical derivation, and so in the expression, so input is R of T, and Laplace transform of R of T, which is R of S, will give 1, and partial fraction of C of S will give 1 by T into 1 by S plus 1 into T. And we are taking inverse Laplace transform, then it becomes the time response. So C of T, it is mentioned as C of T. So here we have the step response of first order system. Here also R of T is U of T, whereas there it is 1 and Laplace of R of S is equal to 1 by S, and take partial fraction and inverse partial fraction, which gives C of T. In the picture we could able to see when there is increase in the time and what happens to the output, but it is getting stable at 0.1, and even if after reaching 0.1, that is at 8 seconds, and even if we increase that seconds to 12, but the output is still remains the same as 1. So coming to RC and RL circuits as first order systems, so the transfer function is 1 by RCS plus 1, whereas in RL it is L by RS plus 1, and taking a similar way, taking for step response and impulse response, we have given the equations. So in this lecture, we have clearly discussed about the time response analysis of first order system, and what is the need for going into this, and what are all the limitations that we have to face, and in order to overcome the limitations, what are all the actions that we have to take, that we have already discussed. And along with that, as considering two standard test signals, which is step and impulse, we have discussed the equations for both first order and second order systems along with the applications. Thank you.